Here is an exponential decay problem. This problem is about population in a city. The population in a city follows the model P equals to 30 times e to the kt, where the initial population was 30,000 residents in 2003. So this 30 represent 30,000 residents in 2003. So 2003, I said initial population, right? So that means 2003 was the initial year. So the population in 2007 was 25,000. The first step is I would like to find the rate k. So this rate k is different in every single problem. Sometimes you are talking about population in the city, the population is increasing, then the k is exponential growth. But this problem I would like to do an exponential decay, so the rate k should be negative. All right, so back to the population model. So the initial year was 2003, and then the initial population was 30. So that means here is what I write a lot. So this one is a P equals to 30,000 in year 2003. So 2003, so that stands for the initial year, so that means t is equals to 0. When you deal with exponential model, the year you don't plug in 2003 equals to t. So you have to find out what the initial time or initial year is, and then let that equals to 0. And then what else do I need? I need the second sentence. So the population was 25,000 residents in 2007. So in 2007, so what is the t then? So 2007 and 2003, so 7 is 4 years later, so t is equals to 4. So the way we do this is we set up using the 4. So we say that 25 equals to 30, and then e to the t is equals to 4, and then you have k times 4. So you don't know k, and then you solve for k. So how do you solve for k? You have 25 divided by 30, right? So you have 25 divided by 30 equals to e to the 4k, and then this is 5 over 6, and then you have e to the 4k. So to bring the k down, we have to take ln on both sides. So I'm going to ln the left hand side, and then ln the right hand side. So on the right hand side, you can bring the exponent down to the front of ln, and then ln e is equals to 1. So that means the next step is you have ln 5 over 6. So you have ln 5 over 6 equals to e to the 4, e to the 4k, e to the just times 4k. ln e is equals to 1, and then what is k? So k is equals to ln 5 over 6 divided by 4. So I would like to see this on everyone's paper. So ln 5 over 6 divided by 4, this is the exact value of the rate. And then ln 5 over 6, 5 over 6 is between 0 and 1. So basically the numerator is negative. When you take ln 5 over 6 divided by 4, I would like to approximate this to 4 decimal places. That is negative 0.0456. 0.456. So let me talk more about this. So should I approximate k? The answer is, according to my style, I usually leave k as an exact answer, leave the rate as an exact answer. But in the previous problem, the previous video, I did not approximate k. So in this video, I want to do something else. I want to try to approximate k to give you a different direction, so you can have a comparison. The first problem did not approximate k, the second problem approximate k. So this is the rate. And then why do I need to box this? Do you see that the k is negative? So what does that mean? K is negative, that means the population is decreasing. So this one I am going to put everything right here because I'm going to follow this. So we have k less than 0. That means the population is decreasing exponentially. So the population in this city is going down exponentially. Now you have k, you can rewrite the model, right? So now the population model, what's the population model? Is population equals to initial population e to the negative 0.0456 times t. Now, the next question is, how many decimal places should I use for k? Now, I do not like approximation because approximation gives you round-off error. But to minimize or to reduce the round-off error, try to use more decimal places. Usually the textbook use 3 decimal places, but to me, my personal preference is use 4. Now, should you use 3? Should you use 4? Should you use the exact answer? Well, when you do your homeworks or your quizzes online, check out the system that you are using. Read the problem carefully. The problem will give you a direction. 3 decimal places, 4 decimal places, or use the exact answer. Read the problem. All right. So now we found the rate k, and then we write the population model. Now I can start answering question. They want me to find the population in year 2022 right here. They want me to find the population in 2022. So I'm going to match the color. So in 2022, so what is k? Sorry, not what is k, what is t? T is equals to, I should take a step back. In 2022, so 2022 minus 2003, that is equals to 19, right? That is 19 years after the initial year. That tells me that the time is equals to 19. Do not plug in 2022 into the population model. So P is equals to 30, and then e to the negative, the k, 0.0456, and then you multiply 19. All right, and then you do this in one line. So that one we have to approximate. Let's use 2 decimal places. 12.61 thousand residents. You plug in a time, you find out how the number of residents in that city. Now, the problems are getting crazier. In the blue question, how long does it take to decrease to 1 resident in the city? So 1 resident in the city, it looks like everybody is leaving that place, right? How long does it take to decrease to 1 person? How long? This one is tricky. 1 resident. I put everything in thousand. Now, let's match the color first. So 1 resident. I use everything in thousand, right? I use 30,000. I use 25,000. I put everything in thousand. But how about 1? Should I just use 1? No, you cannot just use 1. If you use 1 in the model, that stands for 1,000. I am talking about 1 resident. So the 1 resident is 1 divided by 1,000 equals to 0.001 thousand resident. And then to plug in, you plug in 0.001. So 0.001, that is in thousand. But when you say this in thousand, that becomes 1 because you have to multiply this by 1,000, and then equals to the population model. So 30e negative 0.0456, and then t. Okay, solve for t. So in the last question was easy. You plug in the t, 1 step, the calculator tells you what it is, but this one you have to solve an exponential equation. So divide both sides by 30, you have 0.001 divided by 30. This you have the e, negative 0.0456t. And then how do you bring the t down? You ln both sides, right? Okay, I'm going to ln both sides. So you ln the left side, and then you ln the right side. You bring the entire exponent down, and then you have ln 0.001 divided by 30. So you bring the exponent down, 456t, and then ln e is equals to 1. And then what is t equals to? So t is equals to the ln divided by the negative, 0.001 divided by 30, and then over the negatives, 0.0456. So this is the answer in exact value. And then approximate that, use your calculator. Let's approximate that to the nearest integer. So this is approximately 226 years. It takes that many years to reach to one resident. Remember, the population is decreasing starting from 30,000 residents in this city. It took that many years to reach to one resident. And then 2003, so we have 2003 plus 226, so that is equals to year what year? That is equals to year 2229. It takes that many years to reach to one resident, and that year is 2229. All right, so we have another question. If you look all the way up, the purple one, how long does it take to decrease to 3,000 residents? 3,000. Should I still take 3 divided by 1,000? No, 3 is already in 1,000, so we will just use 3. So we have what time it is to achieve 3,000 people. So we will just plug in a 3, that is equals to 30 e to the negative 0.0456t, and then just solve for t. So you have divide both sides by 30, 0.1 equals to that. I'm going to leave myself more space, so 0.1 equals to e to the negative 0.0456t, and then you ln both sides, so ln the left hand side, ln the right hand side to carry the exponent down. You have ln 0.1 equals to negative 0.0456t, and then times ln e, which is equals to 1, and then therefore what is t equals to? T is equals to the ln 0.1 divided by negative 0.0456. This is the time in exact value. When you approximate that, that is approximately equals to 15 years. And then what year is that? Tell me the year. You start at 2003, and then 50 years later, so that is year 2053. All right, so that answers the last question. It takes 50 years to reach to 3,000 people, and then the year is 2053. All right, so that is the end of this question. If you like the way I explain population model, exponential decay, give this video a thumbs up, give my channel a subscribe. Trust me, it is worthwhile coming back for more math lessons. As always, I will meet you all in the next video. Signing out.